Greetings, my dear students. Welcome to question number 5. Let me just confirm. Question number 5, part 2. This one. Okay. This one is only having 2 forces as opposed to the other one which had 3 forces. So let's go ahead and solve this one. So we'll need to express the forces in Cartesian vector form. The first question is find the magnitude and the direction cosines. So we'll go ahead and just do just that. So we know that we have F1. We'll need the position vector OA and get the unit vector. So I'll just go straight and write F1 in Cartesian vector form will be equal to the F1 we've been given multiplied by R OA over the magnitude of R OA, okay, which is equal to 300 multiplied by the position vector for A there is if I am really looking at it, it's 1.5, okay, I, and then we'll have plus 6j, and then plus 4.5k over the square root of 1.5 squared plus 6 squared plus 4.5 squared. Okay, so you do your calculations properly there. There's actually nothing complex, really nothing at all complex. Okay, so you have your F1 to be equal to 58.83i, okay, plus 235.35j plus 176.49 k. All this is in pounds. Fair enough. We get F2 as a vector. It will be the same. F2 magnitude multiplied by the position vector will be over magnitude ROB. Okay, this will be equal to 240 multiplied by we need that position vector, so it will be 1.5 I minus 2j, and what is in the y direction now? Okay, we've been given the angle 60 there, so it's not a problem. So there, that will you can use the tangent function. Okay, we'll need to calculate the z here. Okay, so it's not a big issue. I know that I can calculate, I can, like here, I can calculate for f2 prime using Pythagoras theorem. f2 prime there. After I do that, then I'll use the tangent function to find the z component. So if I've done everything properly, I'm saying that this will be plus the square root of what's this, 2 squared plus 1.5 squared. Okay, then this will be, this is how you get your f2 prime, and since it's the adjacent, it has to be multiplied with the tan of 60, so multiplied by tan 60 degrees. Okay, then over this should be the square root of just that, so you have you have 1.5 squared plus minus 2 squared and then plus this squared. Okay, so this squared will be, let me just punch it in. So let me first just punch it in up there. So this will be tan 60 multiplied by bracket 2 squared plus 1. Okay, 2 squared plus, okay, starting to evaluate. So this is 4.33 squared. Okay, so this part for the k is 4.33. That's what it is evaluating to. I hope we'll all be able to get that. I don't think it is really tricky, not at all. So then here we see that okay, I found a way to move. Okay, sorry, we're trying. Okay, so then what we see is that after we do this, we have to get our f error now. So our f error is equal to f1 plus f2, which is equal to just this Oh, we haven't even calculated the F2 already. So F2 will be equal to according to 72.0i minus 96.0j and then plus 384.33k. So the resultant will be just equal to those. When you add them, you get 130.83i plus 139.35j and then plus okay this one is actually my mistake, 384.33k. So this is not 384, this one, this should be 207. How did I copy 0.84? Okay, so you have that. With this, then we are saying that magnitude of FR is equal to the square root of this 130.83 squared plus 139.35 squared plus 384.33 squared, which is equal to 429.23, and that is pounds. So this is the magnitude here, 429. Yes, so that's the magnitude. 429, let me write it properly. 429.23 pounds. Okay, to get our direction cosines here, we already know our alpha, we know our direction angles. I mean, this will be equal to 130.83 over 429.23, and this will give us 72.3 degrees. Our beta will be equal to cos inverse over 139.35 over 429.23, and this will give us 71.1 degrees. Our gamma will be equal to cos inverse of 384.35 over 429.23, which will be equal to 26.4 degrees. Awesome. Okay. Moving on, we go to finding the component of F1 along F2. We'll basically do the same. So we are saying F1 B is equal to U cross F1 and the unit vector. So this will be f1, sorry, you dot, not cross, dot product with the unit vector in the direction of f2. Okay, right. So we had calculated that unit vector, but I skipped it, so I'll just enter it, and my answer, I have it in. So this is 29. No, 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 no. Okay, no. Okay, so we're going ahead, and we say having to dot that, so you have f1, which is 58.83 I plus 235.35J plus 170 176 0.49K. That's our F. Then dot the unit vector, which is actually pretty much looking a little good, 0.3I minus 0.4J, then plus 0.866K. So you're going to dot this, okay, and technically we should get, if everything is okay, our F, so it's not a vector, our F1B will be equal to 76.4 pounds. Please verify that, and it's simply just the dot product of that. Okay, so this is answer for B. Answer for B. Okay. Let's go to see if we can get our answer for C. Okay, where we need the angle between F1 and F2. Okay, again, it is not a big problem, because you know that your phi in this case is equal to cos inverse of the dot product of the unit vector in the direction of A dot unit vector in the direction of B. I will not solve it, but your answer, your phi, should come out to be 75.3 degrees. That's it. Thank you.